G'day General Math students. In this video we're going to be looking at the relationship between actual data, deseasonalized data and the seasonal index, and it's described by this equation shown here. Okay, there's a useful triangle here shown. Of course you wouldn't get access to that during a test, but with a bit of practice you'll understand how to rearrange this equation to get these equations down here, or those forms of the equation down there. So we need to be able to move between those three within this three variable equation. I'm sure that it's something that you'll be able to get your head around. So we're going to go through a series of examples that utilize this equation, where we're going to be converting between deseasonalized and actual data using the seasonal index. There are several of these calculations, so I'm not going to show what I do on the calculator. I'm going to show the calculation and the answer. You would be well advised to check those calculations as you go using your own calculator. Okay, so let's have a look at the first one. We're asked here to find the deseasonalized sales figure if the actual sales were 13,750 with a seasonal index of 1.35. So looking at those equations from earlier, deseasonalized figure is equal to the actual sales divided by the index. So in this case we have 13,750 divided by 1.35. So if we do that one, we get $10,185.19. Okay, now the next two utilize different forms of that equation. You might want to pause the video now and see if you can figure these out. Then I'll have a go at it and you can check your answers against mine. Okay, I'm going to have a go at it now. So we're asked about the actual quarterly profit for a deseasonalized figure. Just bear with me a moment. A deseasonalized figure of, sorry guys, I'll just get that back. A deseasonalized figure of 25,630 with a seasonal index of 0.93. So the actual quarterly profit is equal to the deseasonalized figure multiplied by the seasonal index. So we multiply those numbers, and that gives us $23,835.90. So there are our first two answers so far. Okay, this last one, the index is equal to the actual number divided by the deseasonalized figure. Now, we could write this out as 1.25 million, like this, 1.25 divided by 1.1 like that, but it's equivalent to this number. Either way is fine. And either way, you should find that the seasonal index is 1.136 if you go to 3 decimal places. Right, let's look at the next page. We're utilizing the same equation, but this time we're given a table of the indices. They say indexes here, but that's wrong. It should be indices like that. Anyway, find the deseasonalized sales figure for quarter 4 if the store actually makes 25,200 of sales. So this means that our actual figure is 25,200. And we're looking at the index for quarter 4, so that means it's equal to 1.3. So the deseasonalized figure is equal to the actual divided by the index. So that's what we're going to get. And if you do that one, we get, if you bear with me, I've got this written down, $19,384.62 is the deseasonalised figure. Okay, you might want to pause now and find the actual figure for quarter 3 and see if you get the same as what I do in a few moments. Okay, I'm going to have a go at it now. So actual is equal to deseasonalised multiplied by the index. So of course our deseasonalised figure is our 12,500. This is for quarter 3, so that is our index, 0.6. So it's really about being able to pick the correct index given the information. Alright, so if we do that calculation, we get 7,500. Okay, last page here, there's still a few to go. We're asked in this case, well, first off, we're given the daily indices for a takeaway shop. So these show the index for each day of the week. We're asked to deseasonalise Tuesday sales figures. So we're going to find the deseasonalised figure, which we're familiar with now, is equal to the actual divided by the index for that day. All right, see if you can do this one. All right, I'm going to have a go at it now. So if you haven't quite got there, you can pause. But the actual figure is $750, and the index for Tuesday is 0.75. So that means a deseasonalised figure of $1,000. Now, you might be able to figure this out finding the seasonal index for Thursday. It's blank at the moment. See if you can figure out, then I'll show you how to do it. Now, with this one, this is interesting. There are 7 days, so the total of all of these indices, if we add them all up together, should be 7, because there are 7 days. If we were looking at quarterly indices like this before, this one, if you add these up, you'll find that they add up to 4, because there's 4 quarters in the year. 1.1 and 1 make 2.1. Plus 0.6 makes 2.7. 2.7 plus 1.3 gives 4. So the total of those is 4. Because there's 7 days in this week, this will add up to 7. So what we do is we subtract all the indices that we have from 7, and that will give us Thursday's index. So just like this. So it depends how many indices are there. If it was a monthly index, there'd be 12 months, so those indices would add up to 12. Okay, so when we do this, we get a total of 0.85. So the index for Thursday is 0.85. You might want to pause now and try this next one with that information in hand. Okay, I'm going to try it now. Actual is equal to the deseasonalised figure multiplied by the index. The deseasonalised figure is 620. The index is 0.85. So 620 times 0.85 is 527. Now, the last one is a worded answer. Saturday has the highest index. What does this mean? Interpret Saturday's index in words. Well, this is a takeaway shop, right? So just thinking logically about how takeaway shops' sales would vary through a week, the most popular days would tend to be towards the weekend. Just with the lifestyle that people tend to live, they tend more often to get takeaway on the weekends than the weekdays. So clearly Saturday is the best day. The fact that it has the highest index means that it's the most sales are usually on a Saturday. Friday and Sunday are both pretty good as well, but Saturday's the very best. And then we see the lowest of the week is the Monday here. Okay, so that's the worst day for sales. So what does it actually mean? How do we interpret this? So Saturday has the highest index. So Saturday clearly has the best sales. Oops, I'll just try and get back there. Okay, so most sales are on Saturdays. Okay, or you could even say they turn over the best profit, or they sell the most takeaway, whatever you like, but that words to that effect. So what does this number of 1.6 mean? Well, if we convert that to a percentage, 1.6 as a percentage by multiplying by 100 gives us 160%. So there are a couple of ways that we can interpret this. We could say that the average for Saturdays, so the average sales for Saturdays are 160% of the expected average of all days. All the days. All right. Now, the other way we could put this, and I'll change to red, the average, I haven't spelt that properly, give me a moment. The average sales for Saturdays are 60% above the expected average of all the days. So the distinction there is with the word above versus the word of. Okay, either way is fine. We can say that Saturdays are 160% of the expected average of all the days, or the average sales for Saturdays are 60% above the expected average of all the days. All right, so go ahead and access the questions that are shown in the description for the video and learn about this equation some more.